Alright, so for question 8 of chapter 15, I'm going to start out this video by, as usual, giving you the answer, which I suggest you try to solve for. And if you are unable to solve for this answer, just unpause the video and you can work through the problem with me. Alright, so going through the problem, first we're given this rate, which off the bat we know is second order because of this 2. So let's just write that down. And going through the question, the above reaction has a half-life of 30 seconds. So T1 half is 30 seconds with an initial concentration of 2.75 molar. So that means that the initial concentration, A naught, is 2.75 molar. What will the concentration of the reactant be after 45 seconds? So what will the concentration be at 45 seconds? Alright, so this is all the information that we are given. Now, because we know that this reaction is second order, we have 2 equations that we're going to use. These equations are ones that you just have to memorize, and when you do this type of problem over and over again, they'll come to you much more easily than when you do it the first time. So I would suggest doing multiple types of problems like this. Now, both of these equations are only for second order reactions. They're not for first order, 0th order, or third order. So that being said, let's just plug in the information that we were given. And let's just kind of bracket in here. Only for second order reactions. Okay, so we have 1 over the concentration of A, which we don't know. So let's just rewrite that. Is equal to 1 over A naught. So we have 1 over A naught, which is 2.75 molar, plus K, which we don't know, and T, which is 45 seconds. All right, and we have T1 half, which we're told is 30 seconds, is equal to 1 over K, which we don't know, times A naught, which is 2.75. All right, so we know off the bat that we can solve for this equation first, only because there's only one variable. In this equation, we have 2 variables, so we're not going to be able to solve this equation until we get K. So let's rearrange this equation to solve for K. We'll have K times 2.75 molar is equal to 1 over 30 seconds. And then we're going to have K is equal to 1 over 30 seconds times 2.75 molar. Right. So let's just multiply 30 times 2.75. 1 divided by 82.5 gives us 0.012 over molar times seconds is equal to K. Now we can plug this in to our equation. So we have 1 over the concentration of A is equal to 1 over 2.75 molar plus K, which is 0.012 molar times seconds, times 45 seconds. Okay, so the first thing we see we can do is cross out our units of seconds, and then we're just going to simplify this equation a little bit further. And we are going to multiply 0.012 times 45, and that gives us 0.54 over molar. Alright, so now what we need to do is find a common denominator. We have 1 here, and we have 2.75 here. So the easiest thing to do would be to make this denominator 2.75. So we have 1 times 2.75 is 2.75. And what we do to the denominator, we must do to the numerator. So we have 0.54 times 2.75, and that gives us 1.485. Okay, so just adding our numerators together, we have 2.485 over 2.75 molar. And from here, we can say we have 2.485 divided by 2.75, which will give us 0.904 over molars. Now I'm running out of room, so I'm just going to bring our equation over here. I'm going to rewrite it just so we don't get lost. We have 1 over the concentration of A is equal to 0.904 over molars. And now all we have to do is solve for A, because that's what the question is asking for. So to solve for A, all we can do is flip this, or you could solve it algebraically if that makes more sense to you. I prefer to solve it algebraically. So what I'm going to say is 1 is equal to 0.904 over molars times A. And now A is going to be molars over 0.904 and that is equal to 1 divided by 0.904, which is 1.106. And we can simplify that to 1.11 molar. So that's the answer that we have found. It matches the one that we were given, and I hope this video was helpful.